Let's talk about liquid 1054 distant barcode. So it gives us integer array barcodes and rearrange the barcodes that no two adjacent barcodes are equal. You may return any answer, and it's guaranteed an answer exists. So it's guaranteed the answer exists. That means the Harris frequency should no more than n plus 1 divided by 2, right? Otherwise, if the Harris frequency is more than this number, we cannot have a solution. Then what we do is that our strategy is that we find the highest frequency. Then from zero index zero, right? Have this number. For example, this is whatever. This is for the example two, right? One, and the index two that is one. Index four that is one, right? Index six that is the one, right? Then we use as rest, right? So it may be here or already smaller, greater than n plus one, then we use from here, right? So just fill the rest numbers in the in this kind of orders. For we have a t, right? Every time increase by two. If you end then set t equals to one. So let's set a record for this. Um, we're going to have int n equals bar codes data length, and we have a max count equals zero, and we can also have a max value, right, equals zero. So we're going to have we can have counts equals new, because this number should be smaller equal to 10,000. We can have new int 10,001, right? So for every int v in our code, we're going to have count v should increase by one, right? So if count v is greater than max count, then we're going to have max count equals count v, and also we'll have max v equals v, right? So as we talk about, it's guaranteed there is a solution, so we don't need to uh, tell whether this max count is smaller than n plus 1 over 2, right? So we just write t equals int t equals t equals 0, and we need a result int. Result equals new int, right? So what we do is that for int I equals 0, I smaller than max count I plus plus. So every time we should have t plus equal to 2, right? And we are going to have result t equals max v, right? So the we firstly fill the max the number with max frequencies, and then fill the rest, right? So what we write is for the like this for int I equals from one I smaller than 10,001 I plus plus. So if I equals max v, or count I equals 0, we just continue, right? Then what we do is that for int j equals 0 is smaller than count I j plus plus. So let's see, if t is greater than n minus 1, we'll set t equals 1, right? Every time we'll have t plus equal 2, right? So we'll have result t equals I. And in the end, just return result. Okay, so it will be O n time complexity with O n space complexity, right? And space, we'll say that is also n 1001, right? So this n plus one 10,001. Uh, we can also write a Python code for the solution. So we're going to have n of the length, right? And we can have count and max count and the max weight, right? So n equals length per pose and the counts, that is n, this one multiplied by 10,001. Count max count the set as zero, max value or set as zero, right? For v in r pose. So we'll have count v which increase by one, right? So if we count v greater than max count, we'll have max count equals count v and also max v equals v, right? Then we fill the heuristic frequency. So we set t equals zero, result equals this one multiply. And then what we do is that for this one in range max v, well, max count, sorry, should be max count. We're going to have result t equals max v, and we have t plus equal to 2, right? Then what we do is for I in range from 1 to 10,001, we're going to have if I equals max v or count I equals 0, we just continue, right? Otherwise, we're going to have, we need for this one in range count count I. We're going to have if t is greater equal to n or t greater minus 1, right? We should have t equals 1. And every time t increases by 2, right? So we have result t should equals I. In the end, just return result.